Okay, now we're going to take a look at question number 8 from Unit 8, Lesson 3, Day 3 homework. Number 8 asks us to use algebraic reasoning and the inverse cosine function to find a solution for each of the following equations. A solution, not all solutions, but a solution. And this is to give exact solutions in both radians and degrees if possible. So again, I'm going to look for those exact values. A half, I see this here, and I see a half here that's coming out. And if I look closely, I might see a half show up here too. So I'm going to reference very closely a special right triangle to help me with this to make sure I have exact values. But since it also says degrees and radians, I think that I will begin using degrees to show you how I would use my Inspire maybe to help me on this, and then to transfer or convert those degrees to radians. So we'll begin with the first one. To get x by itself, I have to isolate x using the inverse cosine function. So I would write out inverse cosine of x is equivalent to the inverse cosine of 1/2. Inverse cosine and cosine will, of course, cancel each other out. They're inverse functions, leaving just x, the input, and the inverse cosine of 1/2. All right, so here's where I'm going to reach for my Inspire. I'll show you what's going on here. I'm going to turn my Inspire on and just go to, I'll go to the sketch pad here. And so we're going to go to the trig. I'm going to go to inverse cosine, and I'm going to type in 1/2. Now, I haven't checked to see what mode I'm in yet, and it looks like I'm in radian mode. I know that because this value, 1.0472, isn't an exact value, and I know it should be if it were in degrees. So that's where I'm going to start this problem. But I'm going to go ahead and switch this over. So I go to Doc, Settings and Status, Document Settings, and I'm going to switch this over to degrees. And I'm going to go ahead and make that my default for now. Okay? And I will try my calculation again. If I don't want to retype it, I can literally just hit enter again, and now it tells me my answer is 60. Hey, that's an exact degree value, 60. So I know this is 60 degrees. But in addition, if I convert that over to radians, I know that I can do that by dividing by 180 and then multiplying by pi. 60 by 180 reduces to 1/3, so I can rewrite this as pi over 3 radians. So there's my first solution. Let's go ahead and try this in the second one. So this one differs because inside of the cosine function we have 5 times x. So when I use my inverse cosine of cosine of 5x, that's equivalent to the inverse cosine of 1/2. The inverse cosine cancels off the cosine, but it leaves the 5x remaining, and then I do the inverse cosine of 1/2. Now I already know from part A that the inverse cosine is 60 degrees or pi over 3 radians. So I'm going to write this as 5x equals 60 degrees, or in radians, 5x equals pi over 3 radians. To finish solving this, I need to divide both sides by 5. So that means that x is 60 over 5. 60 divided into 5 equal parts would be 12. And then this part, if I divide by 5, it's like multiplying by 1/5. Since I'm in fractions, I'm going to stick to that idea, the 1/5 idea. Then this becomes pi over 15 radians. All right, and so those are my exact values. No problems there. Let's go to part C now. Part C, again, I told you it's got a half disguised, but here's why. Now, first of all, you might notice that the book does not have parentheses here. I added those parentheses to indicate further that the 0.4x is the only part that's inside of cosine. You might be confused to say that maybe that was 0.4x minus 1 was all inside, but if the book did that, they would include parentheses around the 0.4x and the subtract 1. So I do know that the subtraction of 1 here is not inside of the function. That being said, I'll start undoing the algebra here by adding 1 to both sides. That will leave 8 cosine of 0.4x equals 4. Then I'm going to divide both sides by 8. That will leave cosine of 0.4x equals 1/2. And I told you the half was disguised in there. There it is, 4 over 8. So at this point in time, I'm going to do the same things I did in the other 2 steps. But instead of writing it out fully, I'm just going to write the fact that 0.4x will be equivalent to the inverse cosine of 1/2. Again, if you need the steps, look at part B and you can see where the step comes from with the cosine and inverse cosine. At this point in time, I know that the inverse cosine of 1/2 leads to 60 degrees or to pi over 3 radians. So I'm going to write 2 statements. 0.4x equals 60 degrees and 0.4x equals pi over 3 radians. The last step, I have to divide the 0.4 out of both sides of the expressions. 60 divided by 0.4. Well, I could do this in my head here, but I'm going to guess that many of you won't. So what we'll do is we'll do 60 divided by 0.4 on the Inspire real quick. And of course, that's 150. So this will lead 150 degrees. Or I could go ahead and do the other part, and I'm going to do literally just 1/3 divided by 0.4 to give you this expression. Okay, so we can do this all in fractions. Or better yet, let's say you don't want to do this fraction divided by a decimal. You could always convert 150 degrees back into radians and go 150 over 180, and then reduce that fraction to 5/6. So this would be the same as 5/6 pi. So there's your final answer for number 8.